Okay, this is part 2 of the video for the metric system notes. And as I mentioned in the first video, we left off on mass, so I'm going to take that up now. The base unit of mass is the gram. And I put the picture of that pen cap up there because you can see that pen cap is almost equal to a gram. It's actually about 0.98 grams. So that's about how, that gives you an idea about how heavy a gram is. Now, here is a first sample problem to work with as far as mass is concerned. And it's asking you this: what is the name given to the unit that equals 1 times 10 to the negative 9th grams? Again, the key here is that the scientific notation times 10 to the negative 9th. We need to find the correct prefix using table 1.5 as we've done before. So what we're looking at here is we find times 10 to the negative 9th there. The prefix that goes along with that is actually nano. And that means 1/1,000,000th of, and that means it's a pretty small unit of measure there. So 1 times 10 to the negative 9th grams is actually equal to 1 nanogram. So very small. This could be like, that could be something like a sand grain or something. Very, very, very light. Doesn't have much mass to it. Now, the second question is this: use standard exponential notation to express 3.76 milligrams in grams. So this is a little bit different, but we still use table 1.5 to do that. So notice we want to go from milligrams to grams. So what we do is we go back to our table. We find the prefix milli, and notice the scientific notation is times 10 to the negative 3rd. Okay, so let's remember that. Times 10 to the negative 3rd. So all we do, 3.76 milligrams in grams would be written like this: 3.76 times 10 to the negative 3rd grams. And that's all you would do for that. Here's another sample problem, and this is another example of going from the metric system to the English system. This question is asking how many grams are in 1 pound. Well, that is not a simple conversion, but we can make it more simple, like we did with the one where we converted from miles or kilometers to miles. So we want to refer to our table, and we want to find a conversion factor to use to convert from grams to a pound. The closest one we can find is right here. 1 pound is equal to 4.536 kilograms. It's not grams, but it is in the metric system. So here's how we set this up. Remember the steps. The first thing is to take your given value, in this case 1 pound, and put it over 1. Then you're going to multiply that by the conversion factor. The conversion factor we have here is that 1 pound is equal to 0.4536 kilograms. But remember, we want to go to grams. So that means we need to add one more conversion factor here. And that is 1 kilogram is equal to, how many grams do you think? Remember, the prefix means 1,000. So that's how many grams are in 1 kilogram. So to do that, you can cross out kilograms, cross out pounds, you're left with grams. So if you carry out your mathematics here, you'll end up with an answer in grams. Okay, so that's how that one is done. Now we're going to move on to volume. The base unit of volume is the liter. And again, another sample problem here. What is the name given to the unit that equals 1 times 10 to the 3rd liters? So again, we want to find, using table 1.5, times 10 to the third. What prefix is that? If we look at our table, it's kilo. So that would mean 1 times 10 to the third liters is 1 kiloliter. A similar problem says to use standard exponential notation to express 3.78 milliliters in liters. So we're going from milli to liters. So we go and look at table 1, table 1.5, find milli, times 10 to the negative third is the meaning, or the scientific notation in this case. So that would mean that we would write 3.78 milliliters as 3.78 times 10 to the negative third liters. Okay. Here's another sample problem. How many cubic centimeters are in 1 liter? Note, I gave you the conversion factor here. 1 cubic centimeter is equal to 1 milliliter. So here is how we would set this up. We want to take the given value. So the value we're given is 1 liter. And we put that over 1. And now we want to start multiplying it by our conversion factors. The conversion factor we're given is 1 cubic centimeter is 1 milliliter. Well, we're not working with milliliters yet, so that's what we need to do first. We've got to convert 1 liter into milliliters. And if you remember your prefixes, milli is 1/1000th of, and if you look that up, it's actually 1,000 milliliters in 1 liter. So that gets us to milliliters. Now we want to go to cubic centimeters. Well, oops, that should be a multiplication sign. 1 milliliter is actually equal to 1 cubic centimeter. So now you can cross out milliliters, cross out liters, and there you go. You will get an answer. In this case, the multiplication is really simple. It's just 1,000 cubic centimeters in 1 liter. Okay. All right, we need to move on to temperature. Temperature is a little bit different because we use different scales in the metric system. So the scales used are degrees Celsius or Kelvin. So if we take a look at the Fahrenheit scale, that's the one that we're kind of used to using. We know that in the United States, we're familiar with water freezing at 32 degrees Fahrenheit. It's kind of a weird number because when you compare that to the Celsius scale, water freezes at 0. Very easy number to remember. Water boils in the Fahrenheit scale at 212. Not many people remember that, but that's the number. Celsius, it's much easier to remember. It's 100 degrees Celsius. So that's why we use the Celsius scale, because it's based on the freezing and boiling of water, and it's set at 0 and 100. So the Celsius scale is what we commonly use in science. Now, how about converting? Well, here are some important equations you want to write down. Here is the equation that you'd use to go from Fahrenheit to Celsius. You would use this equation to go from Celsius to Fahrenheit, and this one to figure out Kelvin from Celsius. Okay, so those are the 3 equations. So you may want to pause the video at this time to go ahead and write those down. Now, real quick, we have a sample problem here. If a weather forecaster predicts that the temperature for the day will reach 31 degrees Celsius, what is the predicted temperature in degrees Fahrenheit and in degrees Celsius? Well, here are the equations that we'd use to set that up. We would simply put in 31 degrees Celsius here to figure out Fahrenheit. Okay? And then we'd also put it here to figure out Kelvin. So I'm running out of time on this particular video, so I can't run through this exact example with you, but we will have some examples on the metric system problems that we're going to work on in class that are similar to this. So see if you can figure this out, and we'll go over this in class.